Hey, all you cool cats and kittens. Mrs. Holm here. Welcome to lesson 1 for the week of May 11th. In today's lesson, we're going to learn about the pH scale and then just a little bit about chemical indicators. So one thing to consider is what happens when you mix an acid and a base. Okay, so we learned last week that acids are generally represented by increasing this hydrogen ion and bases similarly with this hydroxide ion. Okay, so if you mix a positive and a negative, they're going to attract, and H plus OH gives you H2O, water. Okay, this self-ionization of water, we're not really going to get into much this year. Okay, but I do want you to see that sometimes water can break up into these two ions, which shows if you mix an equal amount of an acid and a base, you're going to end up with water, which is neutral on the pH scale. So it ends up being like a teeter-totter with neutral in the middle. And if you have slightly more hydrogen ions, it's slightly acidic. If you have way more hydrogen ions, it's very acidic. Okay, so acids and bases are related. Now, talking about the pH scale, it's the concentration of H. There is a pOH scale, which we don't have to talk about. Thank you, Texas. But the pH scale is all about that acid ion concentration, okay, that hydrogen ion concentration. And the pH scale ranges from 0 to 14. There is nothing negative on the pH scale, okay? So you're never going to say -8 as an answer. That's definitely a garbage answer, okay? 0 to 14. So let's take a look. You'll have this in your notes. Smack dab in the middle at a 7 is what we would call a neutral solution. And it's neutral because you have equal H and OH, which is just H2O, water. Anything smaller than 7 on the pH scale are our acidic compounds. Okay? And our acidic compounds is anything pH below 7, so 6.8, 6.0. And these solutions are going to have the most H plus ions. Okay, just like that teeter-totter. There might be some base in that solution, but mostly it has more hydrogen. Please pause this as you need to fill out your notes. Okay, that's the good part about distance learning is you can pause as you need. Okay. Neutral solutions. We have an equal amount of H plus ions and OH ions. That's why it's water. So neutral is anything that's pH of 7. And then for our basic solutions, those have big pHs. So a solution is considered basic if it has a pH over 7. Okay, so big pH, B for big, is B for base. They have the fewest proportion of these hydrogen ions. So instead of having these H plus ions, they're going to have those hydroxide ions, higher pOH. So 0 to 14. All right, just a little summary for you. So I would say a pH of 5 is an acidic pH, but that would be more neutral than a pH of 1. All right, some common examples would be stomach acid is incredibly acidic, has a pH of about 2. Most sodas, we're talking like Coke and Pepsi and Sprite, they have a pH close to like 3.5. Okay, they're very, very acidic, even though they might not taste very sour. It's because the sugar kind of cancels that out, but that's why it's bad for your teeth. Okay, black coffee, bananas, those tend to be acidic. Okay, regular rain is acidic, and then pure water is on that pH scale, we're talking neutral. And then some really common bases, raw eggs, baking soda that you put in cookies or cakes when you're baking, soaps, ammonia, that's like Windex. Remember we said household cleaners tend to be basic. Okay. Now the pH scale is known as the negative logarithm of the hydrogen ion concentration. And that sounds like a lot. Okay, if you are not into Algebra 2 yet, you've probably not learned about logarithms. So we don't get much into calculating logarithms because most of our students are in geometry, okay, in 10th grade. But this is mathematically what pH means. So lowercase p is the negative log of the hydrogen ion concentration. That's all that those brackets mean, okay? Mathematically, we're not going to be putting this in calculators, and I'll show you why in a bit. Okay, so let's just take a look. pH scale. Neutral in the middle, acidic at the top. So we're talking about a hydrogen ion concentration of 0.1. So if you have a pH of 1, you are 1/10 acid. Okay, 1/100th, 1/1000th. So that means because this is a logarithmic scale, that if you have pure water, a pH of 6 is 10 times more acidic. Okay. If you're talking versus neutral water, a pH of 4 is 1,000 times more acidic than a 7. Okay, it's like an earthquake scale. Okay, so we're talking 10, 100, 1,000, 10,000, 100,000. A pH of 1 is 1,000,000 times more acidic than regular water. Okay, now this, especially when you start looking down here, good, I'm glad that left, at these pH of 13.000000. Okay, this is just kind of nonsense, all of these decimal points. So that's why we use the pH scale. Okay, so in a pure water, a neutral solution, this is mathematically what we would say. 1 times 10 to the negative 7th. That's what this is. Times 10 to the negative 1, 2, 3, 4, 5, 6, 7th. Okay, so this decimal right here is the same thing as 1 times 10 to the negative 7th. And we would use the negative log button on your calculator, blah, blah, blah. The pH would be 7. Okay, so I'll show you guys that trick. It's very easy to find the pH for solutions if the coefficient is 1. And that is this number right here. If your base is 1 right there, then it's very easy to find the pH scale and you don't need a calculator. Okay. All of our examples will be that way. So then the pH is just the exponent, but we make it positive. And I think I have that right here. So as long as this says 1.0 or 1 times 10 to the negative something, that number is your pH. Okay. So here, 1 times 10 to the negative second would have a pH of 2. Right? You just grab the exponent and make it positive. Well, obviously, there's a lot more to this. It's a lot more complicated. You need a graphing calculator, all of that stuff. But we're not worrying about that. Even if we were on campus, we wouldn't be worrying about that. Not until you get to Algebra 2. Okay? So we will always be using a coefficient of 1 in our class. So let's take a look at some of these examples. Okay? 1 times 10 to the negative 4th is going to have a pH of 4. And a pH of 4 means that this is going to be an acidic solution. Okay. 1.0 times 10 to the negative 13th. It's going to take negative 13, make it positive. So 13 is your pH, and 13 over here on the pH scale is basic. And then 1 times 10 to the negative 6th, 6 is your pH. That would be acidic. It'd be closer to neutral, right? But still acidic. So you don't really have to worry if it says H2S and acid or if it just gives you this H+. Okay? We're just grabbing those exponents and making them positive. So it should be pretty straightforward. Let's look at some practice problems. Okay, you guys have this on the second page. Okay, it wants you to first give the pH and then say if it's acidic or basic. And a lot of your homework is going to look like this for this lesson. So here we want to key in on this negative 6 exponent, make it positive. That's our pH. The pH of 6 would be slightly acidic. Okay. Please pause the video right now and try the other 4 problems on your own. Okay, now that you've paused it and practiced on your own, right? Let's take a look at our answers. Okay, pH of 10, 8, 2, and 13. Okay, so big pH is B for big, B for basic. All right, so then you have 3 more practice problems that are going to be very similar to your homework check for this lesson and your end of the week quiz. So again, if you think you can do it, pause it and do them. The first one asks you to circle the solution that's the most acidic. Okay, so the first thing I want to do is cross out anything that's not acidic at all. And that would be those top 2. Okay, pH of 8 and pH of 12, those are basic, they're not acidic. Both of these other 2 choices would be considered acids, but which one is most acidic? We'd say this one. pH of 2 is 10 times more acidic than a pH of 3, even though they're both acids. The second one wants you to circle that solution that's most basic. So that means the biggest pH is most basic. pH of 1 is definitely an acid. Definitely an acid. Neutral. There's our answer. This one is the most basic of all the answers. I could ask you circle the one that's most neutral, and you'd pick this one. Circle the one that's most acidic, and we would have said pH of 1. Okay. Then for the last one, it says, which of the following solutions is closest to neutral? So it doesn't have to be 7. We're just saying which one is closest in this little area right here. So pH of 5, yeah. pH of 6 is definitely close. pH of 1 is not close. pH of 10 is not close. So we would say a pH of 6 of those 4 choices is closest to neutral. All right, and that's what your homework check's gonna look like. So the other stuff we have to talk about today are chemical indicators. Now, chemical indicators can be naturally occurring or they can be just chemicals that you would get in a lab, but it's a compound that changes color as the concentration of the hydrogen ion or the hydroxide ion changes. And that's like our teeter-totter. If they're equal and it's neutral, it's going to be one color. If there's much, much more hydrogen and it's very acidic, then it's going to have a different color, okay? So it's able to indicate if it's an acid or a base, an acidic solution or a basic solution. So a couple indicators that you need to know. Ooh, actually, here's an example first. Hydrangea flowers. I learned this from a different teacher a couple years ago, that these are flowers that will be different colors depending on the acidity of the soil. Okay, so if your soil is acidic for whatever reason, based on what other things have grown there in the past, hydrangeas tend to be more pink, more red. Basic soils tend to be more lavender or blue. Okay. So there are naturally occurring ones. Cabbage is a naturally occurring one. So there's a really, really, really cool DIY lab this week, y'all. It's a cabbage juice indicator. So all you need is a little bit of red cabbage out of a salad or buy a head of red cabbage or just one leaf of it. It's a really cool lab to check out where you can do this in your own kitchen, okay? So the first one you need to know is litmus paper. And this is something to memorize for your homework check. It's really pretty easy, okay? But for litmus paper, acids will always be red, bases are blue, and neutrals stay in the same color. So there's 2 kinds of litmus paper, red and blue. Okay, so an acid will keep red litmus paper red, or it will turn blue to red. Okay, bases will either stay blue or turn red paper to blue, and neutrals will stay the same color. Okay, I'm going to show you this on the document camera in a bit. Okay, but it's easy. Bases are blue. So B for base has a big pH, blue litmus paper B, and B bitter taste. So big blue bitter base. Like I said, I'm going to show you this in the document camera in just a second. Okay, but you do need to know this one for your homework check. pH strips, I'm also going to show you here in just a second, are better because litmus paper just says yes, it's an acid or no, it's not an acid. But it doesn't tell you if it's, if it's a 4 and it's just like Coca-Cola and you can drink it, or a 1 and if you drink it you're gonna die. Okay, so pH strips are a lot better because they can tell you how acidic, how basic they are, how close to neutral. So depending on the sensitivity you need. And then really the best way to identify acids and bases are with pH meters. Okay, so instead of just saying, oh, it looks like it's a 1 or a 3 on the pH scale, okay, depending on which color red or orange this turns, it can actually tell you, hey, that is a 9.18 base, so no big deal, or a 0.72 acid, and it's incredibly dangerous. So our coolest lab of the year is the acid base lab. It is. It is genuinely dangerous. It's terrifying for our teachers because we put dangerous acids and dangerous bases in front of you, and you get to actually do this with the litmus paper, pH paper, and pH meter. Obviously, we can't do that this year, so I've made just a little video to show you the litmus paper and pH paper. Let's switch over to that. All right, let's take a look at some of the indicators that you need to know. You definitely need to know the 2 different litmus papers, the red and the blue, and then you need to know the pH paper. So remember the trick for bases is big blue bitter base. They all start with B's, okay? So we're looking at having, if it's a base, it's going to have a big pH. That means anything over 7, okay? That's going to be blue litmus paper. So that means that blue stays blue, okay? Or red will turn blue. That's how you know it's a base. And then it's bitter tasting. So what I have here are 6 different chemicals that really I just got out of my kitchen. Okay, so A is lemon juice. Let's take a look at A. So I've got red and blue litmus paper. If I stick them into lemon juice, okay, you can see that the red stayed red and the blue turned red. So that tells me if it ends up red both times, this is an acid. Lemon juice is an acid. Duh, right? The second one I have is baking soda, just out of like my kitchen, mixed with water. That's this one right here. Okay. So you'll see that the blue paper stayed blue and the red paper turned blue. So that's big blue bitter base. This would be a basic solution. Baking soda is basic. Okay. This third one is dish soap. Okay, so just like we put in our dishwasher mixed with water. Okay, and you'll see it didn't turn quite as blue, but it definitely turned blue. Okay, so blue stayed blue, red turned blue. Soaps, household cleaning products really tend to be basic. This third one is milk. Okay, it's milk out of our fridge, this fourth one, I guess. And I think, if I can get that one in there. Okay, really both of them stayed maybe a little bit. Oh, you know what? Darn it, I contaminated it with what was on this paper already. Okay, let's try this again. Okay, so I'll put it over here. Maybe this one turned a little bit blue, but really they stayed pretty much their original colors. So milk tends to be pretty neutral, maybe a little bit on the basic side. And that really kind of goes to show you the downsides of litmus paper. Litmus paper is kind of lame. It's a yes or no test. Is it an acid or is it a base? But it doesn't tell you, is milk neutral 7 or is milk a 13 base or is it an 8 base? Okay, so we'll look at the other ones for that. This fifth one is pickle juice, which is mostly vinegar. Okay, and you'll see they both end up red because vinegar is very acidic. And then the last one is just pure tap water. So it should, unless there's something wrong with my water, okay, stay the original colors, okay? So, using just litmus paper, it's hard to tell which of these are dangerous acids or dangerous bases. So really, if you want to be more discriminating, you need to use pH meter or pH paper. So this is pH paper. It's going to change colors to tell me if it stays about the same color, okay, then it's neutral. So instead of just saying, yes, it's an acid, you can figure out what the pH is. So for lemon juice, this first one, okay, that turns pretty deep. And it looks like, okay, probably in that maybe 3 to 4 range of acidity. Okay, let's see. For the baking soda mixed with water, okay, we get this green color. That looks to be about an 8, 8.5. So not a dangerous base by any means, but definitely basic. Okay, let me do that. Okay, for the dish soap. All right. The dish soap, it's basic, but it's like a 7.5. So not as basic as the baking soda was. Okay. Let me dry that off. Milk. This one I'm curious to see what color we get. All right. So the milk looks to be, yeah, right about a 7. Maybe just over a 7. So technically basic, just not very basic. Then I have pickle juice. Okay. Which you'll notice, that one looks to be closer to like 4 or 5 area compared to this one was the lemon juice. Okay, so if I can scoot this, it's really hard to get this to show up, but if I can scoot this, make it lay flat, maybe. It'd be a lot better at school if you guys are doing this at lab tables, let's be honest. Okay, it looks like the lemon juice, okay, is closer to like a 2, 3, where the pickle juice is closer to a 4 or 5 on the pH scale. So there is a difference, it's just hard to tell on camera. And then basic tap water in Spring, Texas, looks to be maybe just a hair. Okay, right at that 7. Not perfect, but pretty close to 7. Okay, so what you need to know for today's end of the week quiz and homework is big blue bitter base. Okay, if litmus paper either turns blue or stays blue, it's a base. Thanks, y'all.